Hi, for this session we are going to be finding the turning point using the average of the x-intercepts. And to explain what we mean by this, let's look at this parabola down here. And you can see how this parabola has two x-intercepts. And we know that sometimes a parabola can have one x-intercept where it just touches the x-axis and keeps going. That's where we have perfect squares. And sometimes a parabola can have no x-intercepts. So to use this method, we have to have two different x-intercepts. And for this example, we can see we have two x-intercepts. Later on, you'll be learning how to use other methods to find the turning point. Okay, so if you look at these two x-intercepts, you can see the first one we have here is when x is -1, and the other one is where x is +3. Now, we know that a parabola is symmetrical, which means it can be cut in half at the axis of symmetry. And we can roughly see here where the turning point is. We aren't given the actual turning point itself. But we can approximately see where the turning point is. And just by inspecting the graph, we can see the turning point is when x is +1. So as approximately, the turning point, so just by observing the graph, the turning point is when x is +1 and y is, if we go across to the y-axis, y looks like it's approximately, we could say -1.5 as a rough guess. Now we're going to find the exact turning point, the exact values in a second. Now, so the axis of symmetry, it cuts our graph exactly in half. And we can see that the axis of symmetry is where x is equal to +1. And you notice that this line here, where I cut my parabola in half, is exactly halfway between these two x-intercepts. And because of that, we can use these two x-intercepts, calculate their average, and find the point where it's exactly halfway on the x-axis. And that will give us the x value of our turning point. So to calculate the average, that is where we add our, in this case, two scores or two values, divided by 2 because we have two values, and it will give us the x value of our turning point. And then we have to find our y value. So let's do an example. Using these two x-intercepts, I'll just make this a bit smaller. So our two x-intercepts, we've got -1. So we can say x, because we're finding the x value of our turning point. So the x values, or the x-intercepts, we've got -1, and we have to add these 2 points, -1 plus a +3, always include any negatives and positives. And because we have 2 points, we divide it by 2. So remember, calculating the average is when you add up your scores. In this case, we have 2 scores, and divide by the amount of scores we have, in this case 2. Now, -1 plus 3, so x will equal, the x value will equal to -1 plus 3. Leaves us with +2 on top, and then on the bottom we have divided by 2. And 2 divided by 2 gives us 1. And what this is telling us is the x value of the turning point is 1, and we can actually see that. So we have found the x value of our turning point. So our estimation by looking at our graph was actually accurate. And now what's left is we have to find the y value of our turning point. Now we haven't been given an equation for this, so we'll do another example where we have an equation, and then we can substitute this x value into our equation to find the y value of the turning point. Okay, so let's just summarize. What we're doing is we are finding the turning point, okay, using a method where we calculate the average of the x-intercepts, and the average will lead us to the exact halfway point of our parabola. And that halfway point we first find is the x value of our turning point. And with the example, we found it was actually +1. And we can see that by looking at this graph. And then our last step is to then find the y value by subbing this x equals 1 into the equation. So for this question, it's asking us to find the turning point of this quadratic equation. And we know every quadratic equation, every parabola has a turning point. So that's something we have to find whenever we are drawing a parabola. An important feature is the actual turning point. Now, let's see what kind of equation we have. We can see we have a trinomial. We've got an x squared at 6x or minus 6x plus 5. And we know to find, we first have to find, so our first step is find the x-intercepts. Okay? Sometimes it may be done for us. It may be factorized or the x-intercepts may be given to us. But in this example, we're starting from scratch. So write down this first point when using this method is you first find the x-intercepts. And how do we find x-intercepts? Remember how to do this? We have to factorize. And then we have to solve, which means we make y equals 0 and apply the null factor law. So we know how to do all of these steps. So let's first do this with this equation here. So to factorize this, okay, let's try that easy method. Is there something times something that can give me 5 that adds to 6? Well, I know that 5 times 1 is 6. And because I've got a positive 5 and a negative here, I know I'll have to have the two values, they have to be negative and multiply with each other. So to factorize this, we'll get our brackets ready. We've got an x squared, so x times x. And now I know I have to have two negatives in here because a negative times a negative will give me a positive 5. And I can subtract them to get a negative 6. So we can have 1 times 5. And that's it. So minus 1 times minus 5 gives me positive 5. And minus 1 minus 5 gives me negative 6. You can expand this to make sure it will be simplified to this equation here. I'm not going to do it now, but that's something you can do. Okay, so now that it's been factorized, we do this next step. We have to solve to find the x-intercepts using the null factor law. So we make y equals 0 because we're finding the x-intercepts. And the null factor law, we know what to do. Make each of these brackets equal 0, okay? And so we end up with the opposite. So x equals a positive 1 for this one, and x will equal a positive 5. And these are our two x-intercepts. And we will be using these two x-intercepts now to find the turning point. So let's just draw a quick sketch and see what we have found. So to graph this, we know we have factorized this equation here to find the x-intercepts. And x was equal to positive 1 and x was equal to positive 5. Now I know this parabola will have a minimum turning point because there is no negative in front of this x squared. If there was a negative in front of the x squared, we know it will be upside down and have a maximum turning point. So I can approximately do a rough sketch of this parabola passing through these two x-intercepts. Okay, I might just fix it up. Okay, now what we have to now find, our second step, is we have to find the turning point. And so for our second step, we calculate the average of the x-intercepts. And this will give us the halfway point. And we know halfway between this point here, 1 and 5, halfway is going to give us our turning point and the x value of our turning point. So we can approximately see by looking at our graph that what's halfway between 1 and 5? Okay, we can roughly, if you want to have a quick guess, you might say 2.5, you might say 3. But to find the accurate answer, we find the average of our x-intercepts. So let's do that now. So we write x. And the reason why we write x is because we're finding that x value of our turning point by finding halfway. So to find the average, we have 1 to positive 1 plus a positive 5, and we just divide it by 2 because our 2 scores. So we'll have x is equal to 1 plus 5 is 6 over 2, and 6 divided by 2 is just 3. And guess what? We have found the x value of our turning point. So halfway between 1 and 5, this point here is when x is 3. And so the turning point, the x value, okay, is a positive 3. And now we have to find the y value. What is y when x is positive 3? And by doing that, we will have our turning point. So now to do this, we've got to get, when x is equal to 3, sub it into our equation, and we're done. So our third step now that you could write down is to substitute the x value of the turning point, which we just found, into the equation to find the y value, and we're done. So we know that the x value of our turning point, so when x is equal to positive 3, we'll sub it into this equation. So y equals, so we always substitute with brackets in case there are negatives. So 3 squared minus 6 times x, or now 6 times 3 plus 5. So we have y equals 3 squared is 9 minus 6 times 3 is 18 and plus 5. So 9 minus 18 plus 5, y will equal to negative 4. And this is our y value of the turning point. And so we have found our turning point. So let's write our final statement. We can say, therefore, the turning point is when x is positive 3 and y is negative 4. And that's it. And they may ask you to draw the graph. So now we can draw a graph of what we have found. So we haven't found the y-intercept, but we have found our x-intercepts by factorizing when x was 1 and y was 5. Okay, now when you draw this, please make sure you use a ruler and a scale. I'm just doing a quick sketch. We have found the turning point, so halfway when x is 3 and y is negative 4. And that's what we found. So let's plot these points. So we found that point, we found that point, and the turning point is right here. So now we can draw a pretty accurate sketch of our parabola. Okay? And if you have to draw, please state the turning point on your graph. So 3, this point here is when x is 3 and y is negative 4. Always show the turning point when you have found it on your graph. And show any other points you have found, like our x-intercept when x is 1, our x-intercept and when x is 5. Now, another thing I want to quickly cover is, how do we find the y-intercept? Okay, this is actually an easy thing to do, and we'll cover it right now. To find the y-intercept, you simply is when x is equal to 0, just like linear graphs, and it's actually really easy. So we'll get the same equation that we just had. So for this equation, y equals x squared minus 6x plus 5. To find the y-intercept, you just make x equals 0. So we have y equals, if x is 0, we'll have 0 squared minus 6 times 0 plus 5. That's going to be 0, that's going to be 0, so y will equal a positive 5. And that's it. Finding the y-intercept when we're dealing with quadratics and parabolas is actually the easiest thing to do. You just make x equals 0 and you're pretty much done. So if we go back to our graph, so this point here, the y-intercept was actually a positive 5. Okay, and that's it. To draw an accurate graph, you have to know how to do all these things. So the first thing we did this term was factorizing. Factorizing to find any x-intercepts. We also have to find the y-intercept. That's an important feature of our graph. To find the y-intercept is when x is 0. And to find the turning point, there is more than one method to find the turning point, as well as to find x-intercepts. But this method we learned was to calculate the average, find the halfway point between our two x-intercepts, and then sub it in to the equation to find the y value, and we're done. Let's try another example. And for this one, we first have to factorize to see what kind of x-intercepts we have. Okay, so to factorize this, let's try that quick and easy method. Get our two brackets ready. X times x is just x squared. It's all positive, so plus and plus. And something times something to give me 9 that adds to 6. Well, I know that 3 times 3 is 9, and 3 plus 3 is 6. And what do you notice? This is actually a perfect square. And so this can be written as y equals x plus 3 squared. So whenever you see a quadratic equation like this, you have to remember that it will look something like this, where it just touches the x-axis and keeps going. So these equations and parabolas are a little bit different to the other ones we have been looking at. And so for this one, If we had to solve and find our x-intercepts, we'd have x plus 3 equals 0, and then x plus 3 equals 0. And when we solve this, what do you notice? We get x equals negative 3 and x equals negative 3. We have the same x-intercept. So for this one, we can't actually find the average, can we? Because it's the same point. We don't have two different points. So for these ones, whenever you see something like this, you know straight away you go to when x is negative 3, and the parabola will just come down, touch it at that point, and keep going. That's where it has just the one x-intercept, or two that are the same, which is just one, I guess. So these equations are a little bit different. Okay, now let's find the y-intercept to then finish drawing our graph as accurately as we can. So to find the y-intercept, it's simply when x equals 0. And you can see what it's going to be. The y-intercept is going to be when y is equal to positive 5 for this one. Because when x is 0, we'll have 0 minus 0 plus 5, which is just 5. So the y-intercept was positive 5. Don't forget to label your axes. And that's all we can do. So for this one, when we have perfect squares, they're actually quite easy because it's just the turning point is also the x-intercept. Okay, and for this turning point, we can see that also, if you want to write the turning point, we can see that the x value is negative 3 and the y value is 0 because it's cutting through the x-axis, that turning point, and when x on the x-axis, we know y has to be 0. So if you were asked to state the turning point, you'd say, well, x is negative 3 and y is 0, and we can see why it's 0. Y-intercept is positive 5, and that's all we can find at this stage to draw this graph. All right, one last example. We'll do this third example. Now, with this quadratic equation, we can see it's not in turning point form because there's no squared anywhere. But what form is this in? It's in factor form. It's being factorized. So they've actually done a step for us. So we don't have to factorize this. We simply have to now solve it to find the x-intercept. So when y is 0, we'll have x plus 1 and x minus 2. And we can just look and see the opposite. So one x-intercept is going to be when x is negative 1. And the other one is when x is going to be positive 2. We can see there is no negative outside the bracket as a factor. So our parabola will have a minimum turning point and passing through when x is negative 1 and y is positive 2. So as a rough sketch, this is what our parabola will be looking like, okay? But we haven't found the exact location of our turning point or our y-intercept. So for this one, because we have two different x-intercepts, we have to find the average of these to find the turning point, okay? So we found the x-intercepts by solving. Now we are finding the turning point. So it's important, I guess, to when doing it this step by step, just write down what you're actually doing. So we're finding the x-intercepts. We're finding the turning point. And to find the turning point, we know how to do this. We're going to find the halfway point between these two x values. So that means finding the x value of our turning point. So when x is negative 1 plus when x is 2, that's the average of that divided by 2. So we'll end up with minus 1 plus 2 is positive 1 over 2. So our x value of our turning point is when x is a half, or 0.5. Okay? And now we have to find the y value of our turning point.